All right, so I want to use this to make sure, first of all, this is on Google Classroom, filling out your periodic table. You should have column 1 has 1 valence electron, 2 has 2, 13 or 3A has 3, 4, 5, 6, 7, 8. These tell you the number of electrons in the outer valence shell that are available for bonding. So I'm going to be using this to make sure that you understand how to show electron dot bonding, like we've been doing. Okay, so first of all, when we're drawing anything in this first column, you want to draw 1 valence electron. Right, so everything down here would have 1 valence electron. So hydrogen, we can put in lithium, sodium, they all have 1 valence electron. If we do these ones in this column, they have 2 valence electrons. So beryllium, I'm going to go 1, 2. Magnesium, same thing, 1, 2. Calcium, 1, 2. So everything in this column has 2 valence electrons. Remember, they're more likely to give up their electrons, their metals, to become positive. Now I'm going to the third column here. Let's do boron, 1, 2, 3 valence electrons. Aluminum, 1, 2, 3. Gallium, 1, 2, 3. So everything here, you just want to draw with 3 valence electrons. We're going to skip 4 for now because we're talking about ionic bonding. But, well, I'll just show you. Like 1, 2, 3, 4. Right, that's even. Remember, in order to be stable, we want to get to 8 valence electrons. So we're not really going to be worried about these ones here because these are not going to be doing ionic bonding. Or not really. Or not in what we're talking about in class. Now we're going to look at these ones in 15. We're going to do nitrogen, 1, 2, 3, 4, 5. There are 3 electrons available for bonding. Remember, we want a stable 8. Do phosphorus, 1, 2, 3, 4, 5. Again, everything down there is going to have the same number of valence electrons. Let's go ahead and do oxygen and sulfur in column 16 or 6A. Oxygen, 1, 2, 3, 4, 5, 6. They have 2 places available to bind. Remember, stable 8. I'm going to go do sulfur, 1, 2, 3, 4, 5, 6. Maybe I'll do selenium too. 1, 2, 3, 4, 5, 6. So you should always be able to look at the columns of the periodic table and it can tell how many electrons are in the outer shell. Let's do fluorine. Fluorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. I'm going to do chlorine. 1, 2, 3, 4, 5, 6, 7. And bromine. 1, 2, 3, 4, 5, 6, 7. So you can see here, here's the open space. These are the nonmetals. They can take in extra electrons. These ones take electrons and they become negative. Right? So if these take 3 electrons, it'd be a -3. These take 2, 2 to make 8. That would be a -2. These take 1 electron to be a -1. These are metals. They're going to give up. And they're going to become positive. So that is like the first part of doing electron dot bonding is you need to make sure that you can draw these accurately. I'm just going to go ahead and show you a couple. Let's say we're going to do lithium oxide. I know that's an Li and an O, but I don't know how many, right? So I'm going to figure that out. Lithium is in the first column, so I'm going to do 1 dot. The oxygen has 6. So I bonded that one. So that lithium became positive, but now I still have an extra electron, so I'm going to have to add an extra lithium because that's the only thing I can have. So right now I have an Li plus 1, Li plus 1, and oxygen. Oxygen got 6 valence electrons. It's a -2. And I make sure there are 2 plus 1s because each of these lithiums gave up an electron. The oxygen is a -2. That is even. Let's go ahead and try sodium fluoride. That's going to have a sodium and a, sorry, I didn't add this. This is lithium oxide. It has 2 lithiums because they each had to give up an electron. So sodium fluoride, again, I look at it's in column 1, so sodium has 1 electron. Fluorine has 1, 2, 3, 4, 5, 6, 7. Na plus 1, F minus 1. 1 sodium, 1 fluorine. This really is going to bleed through. Okay, so hopefully you're kind of getting this pattern. Let's try beryllium oxide. Beryllium has 2, 1, 2. Oxygen, 1, 2, 3, 4, 5, 6. One of each atom, the beryllium becomes a positive 2. The oxygen got 2 extra electrons, so it became negative. Right, there's 1 of each. This is even. What if we did beryllium nitride? So I look back on what's in my periodic table. Remember that nitride, or nitrogen, has 5 valence electrons. Beryllium has 2. 1, 2. Nitrogen, 1, 2, 3, 4, 5. So I'm going to go ahead and add an electron here and here. Now, I still haven't filled in my stable 8, so I'm going to add another beryllium. Oh, now I need another nitrogen. Okay, now I still have 2 extra electrons. Sorry, I drew this kind of funky. Okay, so now all of the berylliums have given up their electrons. All the nitrogens got electrons, so we have beryllium plus 2, beryllium plus 2. Right, and you can look at this and say, this is a positive 6, this is a negative 6. Beryllium 3, 2 berylliums, 3 berylliums, 2 nitrogens. Okay, the other thing, so this is basically what you're going to be doing when you're bonding. Let's just try another one, aluminum oxide. Okay, so aluminum has 3 valence electrons, 1, 2, 3. Oxygen has 6, 1, 2, 3, 4, 5, 6. 1, 2. And I have an extra electron on the oxygen, so I need to add 1 more. Now I'm going to add another aluminum, 1, 2, 3, and 1 more oxygen. Now the aluminums became plus 3. Remember, metals become plus 3. Each of these oxygens become negative 2. Positive 6, negative 6. Our compound has 2 aluminums, 3 oxygens, aluminum oxide. Okay, so again, you want to show how the electrons move. I just want to show you one more. The transition metals, these ones here, have more than one way that they could have the valence electrons. And what I will do is I would give it to you in the name, or sometimes you have to figure out. So iron can be an iron 2 or an iron 3. You can treat iron 2 like this and iron 3 like this. Right? So let's talk about iron 2 oxide and iron 3 oxide. These forms of iron have different properties, so it's important we can distinguish them. So iron 2 oxide, I'm going to draw 2 electrons, oxygen, 1, 2, 3, 4, 5, 6. Well, now I have a iron plus 2, oxygen minus 2. This is iron 2 oxide. You also can tell, if you always know what you did in your assignment, if you always know what the nonmetal is, the charge of the nonmetal, you can figure out the charge of the metal. Or you can think about the electrons moving. So you can look back on your assignment. It walks you through how to figure out the charge. Let's go ahead and do iron 3 oxide. So iron 3 oxide has 1, 2, 3 electrons. Okay, 1, 2. I still have an extra electron, so I need to draw an extra oxygen. 1, I need to draw an extra iron. I still have 1 more oxygen I need to draw. Okay, so now I have iron plus 3, iron plus 3 oxygens. Okay, so iron 2 oxide is iron 2, oxygen 3. So these are both valid configurations of iron. It's really important with the transition metals that you pay attention. They might have a different charge. Again, you could calculate it, but one of the ways you can do this is when you're looking at charges, they kind of like cross multiply. So this would be a +3. It's kind of like cross multiplying. Here it's a -2, so you know this has to be a +2 in order for it to balance.